Welcome back, THS Chem Team, to your next round of video notes. And this is going to be an introduction into the periodic table. So you'll need your periodic table in front of you and what you're writing on, so either a sheet of paper or a page in your actual notebook if you've been given one by your teacher. So let's go ahead and get started. All right, so first off, this periodic table is going to look a little bit different than the one you have in front of you. So the one we have from our reference table looks more like this, and then down here we have two more rows coming off of it. So what this table actually is showing us is that if we actually put all the entire table together, it would be almost twice as wide, and those bottom two rows would be inserted up into the table. And that's because the modern periodic table goes in order of increasing atomic number. So that means that as we move from left to right, the atomic number or the number of protons in each atom or element goes up by 1 consecutively. So hydrogen has 1 proton, atomic number of 1. As we move across, the next one in line is going to have 2, and so on. And by doing this, we have found that the periodic table actually follows a periodic law, and that tells us that the properties of the elements will repeat themselves, or are repetitive or periodic from row to row. So as you drop down a row, the properties repeat themselves. So for example, if we were to look at beryllium and magnesium, since they are on the same column and they're a row apart, their properties, meaning the way they look and act, are very similar to one another. So the properties are repeating themselves. Okay, the table is divided into groups and periods. On the periodic table, a group is going to be a column. So columns go up and down, and we put them in columns and call them groups because they are similar to one another. They look and act alike. Sometimes they're referred to as families too. So a group or a family is a column on the table, and there are 18 groups that are numbered on your table, and that's the way your table numbers it. The old school way to number it would be with Roman numerals, and so some tables, if you look at one that's not yours and you see it and you're wondering how it's numbered that way, is that sometimes you'll see a Roman numeral. So let's say Roman numeral 4, and then you'll see an A or a B behind it. So some of the groups have different numbers in different tables. But the current and most modern table is going to be just a 1 through 18. A period on the periodic table is going to be any row, and there are 7 periods on the table. And so as you move across and go all the way to the end of the row and then start the next one, all the properties will repeat themselves. So that's why we're calling these periods. Okay, so if you're looking at your periodic table, you'll see that you have periods up here, and that's telling you that each period is going to be labeled along the left side of your table. So that means we have 7 rows on the periodic table. Across the top, you're going to see the groups going all the way across, 1 through 18. So you have 18 groups on the table. And in class, we'll get more into what the different groups are and what specific properties they have. But the next thing we're going to point out on your table is going to be this staircase bold line that you see coming down here starting next to boron. And this staircase is going to be pretty much like our dividing line for the table. So it divides the table into 2 very specific categories. Okay, and those categories are, the first one is going to be anything that is to the left of our staircase is going to be considered a metal. And again, this starts right here next to boron and then works its way down. So all these blue boxes for the elements are considered metals. And anything that is a metal is going to be a good conductor of a heat or electricity, and that means heat can flow through it easily. It's going to be malleable. So if we were to hit it with a hammer, it doesn't shatter, it only flattens. And almost all of the metals are solids. We'll talk in a little bit exactly which ones are not. Also, the last thing is that metals, when they form ions, will make positive ions, and that means that they are giving away or losing electrons. Okay, so if we know that the left of the staircase, all these blue boxes are metals, that means to the right is going to be the opposite of a metal, and that's going to be nonmetals. So again, here's our staircase starting next to boron and working its way down. All these orange boxes are considered nonmetals. And you see we have one outlier over here, which is hydrogen. Even though it's over here on the left side of the staircase, he is still considered a nonmetal. So to the right or above the staircase are nonmetals, and they're going to be pretty much the opposite of a metal. That means they're going to be poor conductors, so they don't let heat or electricity run through them easily. They're going to be, most are gases, and the ones that are solids, the few that are solids, are brittle at room temperature, so that's the opposite of malleable. If we hit it with a hammer, it shatters. And they tend to make negative ions, which means instead of losing their electrons, they gain or take electrons. Okay, and then you see on this table, it's not color coded on yours, but on this table you see this green group right along the staircase. And these are going to be referred to as metalloids or semimetals. So what that means is that the semimetals or the metalloids are neither consistently a metal or consistently a nonmetal. They're kind of in between. So they're going to be like our transition from metallic on the left to non-metallic on the right. And the big property that a lot of times comes up where you'll hear of semiconductors. Semiconductors typically fall in this semi-metal or metalloid range. And so they have the ability to conduct electricity under certain conditions. The other thing that you're going to notice is that not everything that's on the staircase here, the pattern isn't consistent. So typically the general rule is if an element is on or beneath a stair in our staircase here, it's considered a semi-metal or a metalloid. The only one that doesn't follow that is aluminum. Aluminum's properties are definitely metallic, so it is considered a metal, even though it is just beneath a stair right on that staircase. It's not a metalloid, it's definitely a metal. All right, the last classification for this round of notes is that you need to be able to identify the solids, liquids, and gases at STP, or standard temperature and pressure. So on this color-coded table in front of you, yours doesn't have this, but your solids on this table are going to be all the ones that are printed, the elements are printed in black. And you can see that the majority of the table has black for the symbol. So all of those are solids at STP. Liquids on this table are blue. There's only two of them. At STP, you have mercury and bromine. So you have one metal and one nonmetal that are found as a liquid at STP. The gases are red. And there are no metals that are a gas at STP. All of your gases are going to be found over here on the right part of your table, the extreme right, where all the nonmetals are. Again, with that one exception being hydrogen, is way over there on the left. But the most common thing that comes up that you may want to keep track of are where the liquids are. You have one metal that's a liquid, which is mercury, and one non-metal that's a liquid, which is bromine. So that's it for your quick introduction to how the periodic table is set up. Key things to remember: it is set up in an increasing order of atomic number, or protons. It's organized into different periods or rows so that every row the properties repeat themselves, and every column is considered a group or a family on the table because they have properties that are very similar to one another. Good luck. Bring some questions to class. We'll have some more activities going.